Okay, we're going to talk about simple linear regression in this video using phstat and then using Excel. So we'll start by using phstat. Now, simple linear regression, I have a chart here. I'm going to use price and quantity for my simple linear regression and put those two against each other. And I'll just say if I find a quantity of a certain amount, what would the price be that I find? So I'm going to make price my dependent variable based on quantity. Okay, so let's try that on phstat. So first I've got to get phstat loaded in here. There it is. Okay, I've got it. Simple linear regression. See if I can, with all the data I collected, see if I can get a connection mathematically between price and quantity. So I load in my y variable, which I'm going to make the price. That's here. My x variable will be the quantity. So I've loaded in here. Okay, and then I'll ask for my regression statistics and a residual plot and a scatter plot. Let's go do that. Alright, let's go to the scatter plot first. There it is. Now look, if I pull this over here, it tells me what the best fit line is through those data points. That is the quantity versus price data points. And we have quantity on this axis here, we have price on this axis. And the equation that defines that line right there is this equation, minus 6.0034 times x, which is the quantity, plus 176.43, which is the intercept up in here somewhere. Okay, and the r squared, that's the coefficient of determination, is 0.5169, which means 51.69% of the variation we see in points here is explained by that line right there. So we have explained what appears to be 51.69% of the variation we see in price when the quantity changes. Alright, and now we want to go back now and produce these same results using the Excel. So to do it on Excel, what I usually do is just create the scatter plot first. Alright, so we will say insert a scatter diagram, that's that, and go to design, select data, and add, and now our x values are the quantities. I don't put labels on this one. The charts in Excel don't work when you have labels in them. And I need to put in the other one, which is the y values, price, like that. And that is my scatter diagram. And now what I'll do is click on one of these, right click. I right click on one point, say add a trend line. It asks me what kind, I say linear. I display the equation on the chart, I display the r squared value on the chart, and pull this out of here like I did the other one. And what we have is the exact same results here as we have on that scatter diagram there. So that's how you do the one on phstat and how you do it on Excel. Now the one last thing we got to worry about is the residuals. Now, as it explains in the text, the residual is if I take this line, this equation that I have, and I calculate what the price would be at a given quantity, what will my scatter plot look like? And if my scatter plot has the appearance of a line, it indicates that I don't have causation. What it's saying is that there's something else related to x, which in my case in this problem is quantity, that might be changing the value of the price and not the quantity. So if there is no relationship on the scatter plot or residual plot, we'll see that. Okay, so let's see what the residual plot looks like in the phstat. Okay, there is no straight line that goes through this data with any kind of accuracy. Therefore, quantity, which is my x variable, is not related to the residuals, the errors in the predictions of the line. And so therefore, I can conclude that that 51.69% of the variation that I explained could very well be a change in quantity. But if there was a straight line going across there with my quantity against my residuals, then I would have to conclude, well, there's something else that's varying also, because it's varying with my residuals vary with quantity. Alright, so now I have to do that again only in Excel, to show how we do that in Excel. A little more complicated. We take this quantity column and we copy it and paste it over here, for example, and then take the price column and we copy that, put it in the one removed. Alright, now here we're going to do the predicted x. That's going to be what the price is based on the equation. Okay, so the equation says that price is going to be equal to minus 6.0034 times quantity times quantity, okay, plus 176.43, enter. Okay, so that's what the equation says the price would be, and that's what that actually is here, because that is the actual value that was loaded in, the actual data value loaded in versus the calculated. So I copy those all down, and the difference between those two is the residuals, and the difference between this one minus this one gives me the residuals, and I can copy that down. And now if I make another plot, insert scatter diagram right here, we're going to make another plot, and on it it's going to be, we'll remove the one that's there now, we'll add in a new one, and it's going to be the x values are going to be quantity, just as before, and then the next one is the residuals. There. Say okay. Okay. Now that, as you can see, is the very same plot as we got with the pH stat, and again, there's no clear line there. So what we've established here is that there is a relationship between quantity and price, that when quantity changes, price changes. And we know that from the data that we took, that about 51.69% of what changes price is connected to the quantity changing. And we also have confirmed that our residuals using the equation, the error that we get in predicting price, is not creating a relationship between the two, which means that we don't have something else operating here that might be explaining that 51.69%. It could very well be the quantity. Okay, so if you have any questions on that simple regression and the residual discussion, let me know. But that's in your book, and you can let me know if you have any questions. Thanks. Bye.